Welcome to the Core 2 video for our supplemental homework evaluating with fractions. So evaluating functions when we have fractions. We're going to start off with evaluating functions with whole numbers. Get the idea of what evaluating means, and then we'll actually do the fractions. So we'll start off with problem number 1 on the supplemental homework. Be a good idea to do this if you feel you need more work on fractions. So I'm going to zoom in, and we will work problem number 1. Problem number 1 says g of t equals -2 minus 2. Find g of 9. So I start off with g of 9 equals -2 times 9 minus 2. Wherever I see t, I plug in g because I want g of 9. -2 times 9, -18. -18 minus 2. I'm going to draw a number line really quickly. Always a good idea. -15, -16, -17, 18. I start at -18, and I go down 2 since I'm subtracting 2. -19, -20. So mine's -20. G of equals -20. Okay. Take a quick look at number 1 and 2 and see if you can evaluate h of 9. Okay. Once you're done, pause the video while you do that. Once you're done, come back and I will put the answer up. Okay, now that you're back, I do 4 times 9. 4 times 9 is 36. 36 minus 3 is 33. Okay. If you didn't get that answer, go back and watch the first part of the video, see if you can get that. Otherwise, let's go on, work on problem number 3. Pause the video quickly, see if you can get an answer to number 3, and then you can check it when you come back. Okay, now that you've worked problem number 3, we need to find g of -6. The function says take whatever x is, subtract or add 1. So I'm going to have -6 plus 1, I get -5. Okay. If you don't see where that came from, try again, watch the video again, see if you can get that. Okay. If you're ready to move on though, try problem number 4. I will pause the video, I will give you a chance to work on that, and then I will give you the answer. Okay, now that you have worked on problem number 4, we want g of 6. G of x equals 3x minus 1. I take 3 times 6 minus 1. 18 minus 1 is 17. If you weren't able to get that, watch the first part of the video again and see if you can figure out what you did wrong. Otherwise, let's move on to the second one. The second set of problems are quadratic problems, but we're still evaluating by plugging in the whole number. So we're still not using fractions. Essentially, we're plugging in the same way though. This p of 8, we want p of 8, tells us that we want a to be 8. So p of 8 equals 8 squared plus 1. 8 squared means 8 times 8. That's 64. Then I add 1. P of 8 equals 65. Take a quick look at number 6 now. Pause the video, see if you can do number 6. When you have gotten an answer, come back and you can check your answer with mine. Okay, number 6, we want p of negative 6. This is a little more complicated. I'm going to write out a little bit more. Negative 3 times negative 6 squared minus 5 times negative 6. So we had an extra x term in here. We're going to have to take that into account. Also, we're squaring a negative 6. A lot of people have trouble with that because if you put negative 6 squared in your calculator without the parentheses, the calculator squares the 6 and then makes the 36 negative. But negative 6 squared literally means negative 6, p of negative 6 equals negative 3 times negative 6 times negative 6. We do not want a negative number because we're multiplying a negative times a negative. Minus 5 times negative 6. PEMDAS tells me. Well, first of all, I've done my exponents. I've changed my exponent into multiplication. So I've done my exponent first. Now I do my multiplication. Parentheses next to each other mean multiply. The 3 next to the negative 6 means multiply. So I'll do negative 6 times negative 6. Negative times negative does give me a positive. So I have 36 times negative 3. 3 times 36 is 90 plus 18. 3 times 30 is 90. 3 times 6 is 18. I add them together, I get 108. So I have negative 108. And then I have 5 times negative 6. I can think of that as plus negative 5 times negative 6. Negative times a negative is a positive. So I add 30. And in my mind, I have to add 30 and negative 108. That's the same as 30 minus 108. And when I do 30 minus 108, I actually do 108 minus 30 and make the answer negative. So I end up with p of negative 6 equals negative 78. If you think you're ready, let's go on to the quadratic. I'm sorry, those are the quadratic equations. Oh, no, sorry, 2 more. You need to work on number 7. Number 7 should be pretty straightforward now. Give you a chance to do that. When you're done, restart the video, and I will show you the answer. Okay, now that you're back, negative 3 squared is positive 9, because I do negative 3 times negative 3. 2 times 9 is 18, and then I have to subtract 2 times negative 3, or add negative 2 times negative 3. So I end up with 18 plus 6, p of negative 3 equals 24. Try number 8 now. Pause the video really quickly, number 8, and then come back and you can check your answer. Okay, you plug in negative 5 for n squared. I'm sorry, you plug in negative 5 for n, so we do negative 5 squared. Negative 5 times negative 5 is positive 25. Positive 25 minus 5, we get f of negative 5 equals 20. All right, let's move on to the fractions. Hopefully you are feeling comfortable with plugging in numbers, plugging in whole numbers. We're going to do the same thing now, but we're plugging in fractions. We have to work with fractions. Fractions in equations and functions work the same way as whole numbers, except that when we multiply, we have to multiply fractions. When we add, we have to add fractions. When we subtract or divide, we have to subtract or divide fractions. So that's the challenge here. Solving is essentially the same, but you have to think about what it means to subtract a fraction, what it means to multiply a fraction. We can't just multiply and then subtract. We have to multiply a fraction. So let's get started with that. We want g of 14 over 9, which equals 1/4 times 14 over 9 minus 8 over 5. When we multiply fractions, we multiply the numerators, we multiply the denominators, and I'm going to really quickly just do a quick demonstration. We could multiply 1 times 14, get 14 and divide by 4 times 9. 4 times 9 is 36. But those are both even numbers. I can divide them both by 2, and that will make my life a lot simpler if I do that. What makes my life even simpler is if I do it before I multiply. I am going to divide the 14 by 2, and I get 7. I divide the 4 by 2, and I get 2. And once I do that, now I multiply. So g of 14 over 9 equals 1 times 7 divided by 2 times 9, which is 18, minus 8 over 5. I've got a big challenge now. I have different denominators, and I cannot add or subtract different denominators. I have to make the denominators the same. So I am going to think about what factors I have. The only way I can multiply to get 5 is 1 times 5. I cannot multiply by 5 to get 18. I can multiply by 3, I can multiply by 2, I can multiply by 6, I can multiply by 9 to get 18, but I cannot multiply by 5. So I have to multiply 5 times 18. So I end up doing times 5 times 5. If I multiply the denominator, the numerator gets jealous. I have to multiply the numerator by 5 as well. So I'll do 5 times 18. In the second fraction, 8 over 5, I'm going to multiply by 18. That's going to give me the common denominator. I get the same denominator because 18 times 5 is the same as 5 times 18. Once again, though, if I multiply the denominator by 18, the numerator gets jealous. I have to multiply the numerator as well. So I end up with g of 14 over 9 equals 7 times 5, 35. 5 times 18, I'm going to divide the 18 by 2 and then multiply the 5 times 2. So I make one smaller, I make the other one bigger. I end up with 10 times 9, I get 90. Minus 8 times 18, 8 times 10 is 80, 8 times 8 is 64. I add those together, I get 144 over, again, 5 times 18, same as 10 times 9, I get 90. Now I have a common denominator. Once I have a common denominator, I subtract the numerators. I found a common denominator. I'm going to keep that common denominator. G of 14 over 9 equals. I do 35 minus 144 technically, but I can find that answer by doing 144 minus 35. 144 minus 35 gives me 109. But since I'm subtracting a bigger number, my answer is negative 109. So that's working with fractions. There are a lot of things you need to remember. When you multiply the tops, the numerators and the denominators, tops and the bottoms. When you add or subtract, you have to have a common denominator. Multiplication and division, you do not need a common denominator. just complicates the problem if you try to do that. But with adding and subtracting, you need a common denominator. Okay? Basic rules of fractions. May need some practice to try and remember those, but they will be on PSAT. So let's try to do that. Take a moment and work on problem 10. When you come back, I will give you the answer. So you're plugging in 1/9 for x. Okay, for number 10, you plug in 1/9. So h of 1/9. Really a lot simpler than problem number 9. But hopefully it was easier for you. 1/9 plus 1. 1 is the same as 9 over 9. We end up with 10/9, or actually we really need to change that back to a mixed number. There's 1 9 in 10. I take out 9/9 to make 1. I end up with 1/9 left over. You probably could have gotten that directly from just adding 1. That's great if you can do that. Take a quick minute now and see if you can do problem number 11. Okay. Pause the video. If you can answer, come back, you can check that answer. Okay, I was in now 4 over 3. So h of 4 over 3, end up with -1 plus 1/4 times 4 over 3. I cancel the fourths. I end up with -1 plus, I get 1 over 1 times 1 over 3. End up with 1 over 3. I think about the -1 as negative 3/3. I add 1/3. So I lose 3/3, I get 1 back. I end up with a total of -2/3 equal to h times 4 over 3. Okay. Take a quick look at number 12 now. Pause the video. See if you can answer number 12. When you have an answer, restart the video and you can check your answer. Okay. h of 9 equals, I'll go ahead and write it all out for you. 2 times 10 over 9 plus 2 over 5. Two times 10 over 9, that's the same as 2 over 1 times 9. We multiply the numerators, we multiply the denominators. 20 over 9 plus 2 over 5. And I have to get a common denominator. The easiest way to do that is 5 times 9. But if I multiply 9 times 5, the 20 gets jealous. I have to multiply the 20 by 5. If I want something that's the same as 9 times 5, I can do 5 times 9. Those are the same. That gives me a common denominator. If I multiply the denominator, though, I have to multiply the numerator. Twenty times 5 is 100. 5 times 9 is 45. 2 times 9 is 18. 45. I add 100 plus 18. Because once I have a common denominator, that's the denominator in my answer. But I need to add the numerators, 118 over 45. Thank you very much.